you are. So just put in there where you're coming from. That's a fantastic beard, Sam. So a lot of work has gone into that this morning. Anthony, thanks, Anthony. Emma up in Gladstone. It's got to be warm in Gladstone today, I'd think. Starting to get a bit muggy, is it?
Ian, can I add to your request that people put kind of what industry are you in? So I've got an idea about, are we pointing at what is it, utilities? Is it mining? Is it aviation? Is it what is it that you can put that in the chat as well?
Oh, Anthony, look at them. You're a gamer. Look at there's all of them stuff behind you.
Oh yeah, collector of lots of bits and pieces, pop culture.
Is that Star Wars there?
Yeah, we've got a bit of Star Wars gear there. Yeah. Some old audio equipment there.
There's an old Ericsson one-piece phone. I haven't seen that since
I picked that one up recently at a retro shop. It's a good find, that one. It's in pretty good condition.
It's got the dial on. It's got the dial on.
It does. Yes, it does.
No, it's Frank. Yeah. I don't understand.
Yeah, it's a classic, that one.
We used to have one of those.
I'm glad it's a phone, because I wasn't sure what it was, frankly, from when I first got
it. It looks like it could be rude, eh, Ian?
You thought about it like
a little bit. So that's good. It's good. Folks, if I could just ask you to put your where you're coming from and the industry sector into the chat, that would be great. And even if you just put your camera on for 2 minutes, give us a wave, and then you can disappear, or at least to just let us see you briefly. Sonny coming from Glenbrook in New Zealand. Thanks, Sonny. A few more coming in. Brisbane mining. That was a very brief wave. I like it. We'll give it a couple of more minutes, and then we will kick off. Folks, if you just joined, if you could just put in the chat where you're from and the industry that you're in, would be great. Okay, I tell you what, we will kick off, and then David, when people do come in, just ask them again if you want to put in there their title or their organization or where they're from and their industry sector. Okay. So, folks, thank you. I think it's morning for most of you. Everyone seems to be coming from Australia, New Zealand. Thank you for joining us this morning. You're in for a really nice session for the next 90 minutes with David Hodes, who is from Ensemble Consulting Group. The session, Busting Maintenance Bottlenecks. He's told me a little bit about this. It's going to be super interesting. And David is the CEO of Ensemble Consulting Group and the author of More Than Just Work. David and his team have guided billion-dollar projects across mining, construction, manufacturing, and aviation with the TOC approach. So without further ado, over to you, David.
Great. Thank you, Ian. And let me get this thing going. And let's go all the way to there. And just bear with me 1 second. Right. Can everybody see that all right?
Yep, I can.
Okay, so from time to time, I'm going to ask people, if you've just joined and haven't yet written into the chat, who you are and what your industry sector is, because what I want to do is I want to make this kind of interactive, which means that I want you guys to chime in when you have the opportunity. Because what I'm going to propose to you is that this idea about the theory of constraints is a universal. It's a law of nature. It's like gravity. So I think first up, what I'd like to do is to ask, and I don't know whether you put it in the chat or how does it work. Zoom's got a thing where you can actually do surveys. I don't think we want to do a survey, but just a quick kind of an idea of who's heard of theory of constraints, or who's used it, or is this whole new territory for some people and old hat for others? Anybody want to chime in? Anybody who's done something with theory of constraints? Maybe you can just give us a quick little brief on that.
I was going to say I've heard of it, but that's because I spoke to you, David, at Mainstream about it.
Okay. Anyone else? I'll take that as a no then. So we're into whole new territory here. So I'm making this claim that it is a fact of nature. And if I go back all the way back in the day when these two guys were still alive, I actually first came across this stuff when I was running a commercial refrigeration company. In fact, South Africa's largest commercial refrigeration company. And what happened was that there was a boom going on in South Africa as a result of Mandela being released, and then the whole way that the country was moving. And we ended up that we had way more work than we had people to do it, because not only had there been a neglect of what needed to be done in terms of overall maintenance and, in fact, projects, because we were putting in new kit as well. But there was a degrade in terms of the number of people that there were available to do it, because the apprenticeship programs had been left to go fallow. And so very, very few people to do things. And by heroic efforts, we got the first tranche done. And that led into me learning about this theory of constraints. There was a place in Pretoria called the National Productivity Institute, and they had a section called which was a whole productivity piece that included lean and agile, not agile, lean and Six Sigma, but it also had a theory of constraints thing, and that seemed the most appropriate thing at the time. And where I landed initially on the project management side of theory of constraints. And so we managed to turn a 71-day refit of a supermarket into 56 days. And that changed, that number of days saved meant that I had that labor pool that I could go and do a regular size supermarket. And it was just blew me away the extent to which a productivity improvement could actually deliver such a big advantage. And what I got at the time was these two books from the National Productivity Institute. And the one on the right was the most relevant at the time, because the goal is multi-million seller. And it's a recommendation that I would have for everybody to just go and get a copy of it. It's a novel, and it's about this guy called Alex Rogo, who's the sort of factory manager of a plant, and they're in deep trouble and they're not making enough money, and the big shot comes and tells me he's going to close them down and everything. And it just walks through how they take these ideas of the theory of constraints and goes from being the worst performing to the best performing. And then on the other side is the fifth discipline, which was a guy called Peter Senge, who, interestingly enough, is an engineer, aeronautical engineer from Stanford, then went to MIT. He worked with a guy called Jay Forrester, who invented the memory chip, believe it or not, and they were very involved in dynamic modeling. And when they looked at systems, they were talking about what is it that from systems thinking perspective delivers the kind of results that we want to get, and how do people within organizations learn? And that's a key part of what we're talking about. And so my invitation to all of you today is to take a leap, to think about if you change the way you look at things, then the things that you look at change. And if you haven't yet heard of the theory of constraints, I would urge you strongly to go and find out more. There's a ton of stuff available. If you Google, you can go to our website, you'll find an enormous amount. There's all sorts of things, but it does require, I dare say, some courage, because it's about changing the way that you work. So let's go and have a look at what this is. So here's just a small sample of the kinds of people that we've done work with. In the sort of asset side of things, I guess it's more the engineering companies there. Did I see a Blue Scope person there somewhere? At any rate, there's a One Steel thing and so forth. The kind of results, they're big. Normally, I would make the claim that you can deliver probably a 25% minimum increase in productivity by applying the theory of constraints. And oftentimes you can do a whole lot more than that. So what is a constraint? Does anybody want to tell me? What's your constraint in your business? Don't be shy. David Kidd, you've got your microphone open. How about you tell us? Give us your picture, if you wouldn't mind opening your camera while you're telling us. David? Come in, David. Nope. Anyone else?
Yeah, I can chip in with a couple.
Thanks, Anthony.
Well, there's quite a few common ones for us. We're in energy infrastructure and we're service providers to those people that own the assets. But access to the assets is a very common constraint. Also, resources, having enough resources to meet the demands at certain times. They're two pretty common constraints we have, and weather and seasonal impacts as well, which also affect that access to certain assets.
So it sounds you've got narrow windows of availabilities where you've got to go and do the work, and then the issues around then coordinating the variety of resource types that are there to go and do that work, and that can be impinged by weather and other events.
Yeah, that's right.
Just when you thought you had the availability, suddenly a storm comes through and you ain't got it anymore. And
well, that's right. Or you have a particular part of a network or an asset failure, which then jeopardizes all the pre-planned work in that area, or takes the resources away from that pre-planned work.
Okay, so I was thinking about if we take the systems lens, what is the purpose of maintenance? We're talking about busting maintenance bottlenecks. So anybody want to tell me what's the purpose of maintenance?
Yeah, David, this is Sunny Singh from BlueScope. New Zealand still in Glenbrook.
Sure.
I guess the purpose of maintenance for us is to, keep our assets operating efficiently and ensuring our operational capabilities are maintained. The products that we create at our facilities continue coming out prime, 100% quality, and keep our non-prime down to a minimum. That's really the biggest goal we've got as a maintenance asset manager, is to ensure we can maintain the assets to the utilization that we've set.
Okay, good. So what I've found in terms of maintenance and maintenance bottlenecks, which is the topic for today, and tell me if this is true in your world, is that there's a tension. There's a tension between operations and maintenance in the first place, because, a bit like Ian was saying, that you've got this availability, because in production planning that they have, they say, here's a slot that you can go and do your thing. And if you could do it somewhere between midnight and a minute after midnight and get everything done and get out of our way so we can keep producing, that would be a terrific world that we're living in. So that's one tension that's there. Another tension is always about this idea that, well, maintenance is a cost, right? And because maintenance actually doesn't produce anything, then they don't necessarily look at it in terms of saying what it enables in terms of production. Is that still the case? I can remember being at a mainstream conference, I don't know, 2002 or something. And there was this whole thing going on about, can we get away from maintenance as being a cost and maintenance as being something that serves production? So I don't know, Sunny, is there that tension in
Yeah, the first part is in terms of availability of time, because we have our operations are 24/7 operations, and we only have I think Anthony mentioned earlier, we have very limited time to do maintenance. Our maintenance windows are once every 14 or 16 weeks apart, right? For one day on one facility and another day on another facility. So it's very, very, and that's planned, that's available, that's understood. But we also have what we call opportunity time, and those opportunity times are, like as you said, middle of the night. We can never, there's always a tension around trying to get that at a time where we have our resources available, because our resources Monday to Friday, day shift only. We don't have them working around the clock. We only have a limited number of people around the clock. So there's always the tension to try to juggle the availability at a time when we've got resources. The second part around maintenance as a cost, I guess I'm a bit lucky. Our organization is pretty mature in the sense of understanding the maintenance requirements, because it does they do understand that it is part of the business that we have to incur that cost. So we don't really have that tension, other than accountants every so often wanting to slash the numbers down year on year.
Yeah. Okay. I'm just interested. I can see here Anthony Cook. Anthony, you with utilities and energy infrastructure. Are you able to just give us a little bit of a on what your take is on what's your bottlenecks?
Yeah, well, as I was saying before, you know, because we work on from a maintenance point of view, we construct as well. But from the maintenance point of view, very much it is coordinating that access to assets, because most of the assets we work on, they're in networks or they're connected to networks. So, you know, getting that piece of the network out of service can be challenging depending on where it is. Also depends on if it's a connection point, like a customer connection point, that has even more, I guess, constraints in it too, because then you're talking about having to align with what the customer needs to do on their asset as well. So, you know, they've got maintenance they need to do. We're doing maintenance for our customer who's on the other side of the connection point. Then also there's some of those seasonal issues as well, because seasonal issues might mean, you know, weather conditions that impinge you being able to do maintenance or inspecting assets. A good example is in the transmission line and power line space, that if it's cropping season, well, you can't be, you know, putting people into those areas to do work. You have to, you know, schedule it once the crops have been taken off, type thing. You've also got loads to consider. You know, in summer you've got peak loads. Winter, believe it or not, in some areas of networks there's also peak loads. So, you know, you've got all those things in play, and then you're trying to manage your resources, because you don't have an unlimited amount of resources and where you've got special skill sets as well, they're quite limited. So you often find yourself really trying to juggle, you know, a plan is like a 3D puzzle a lot of the time.
Yeah.
You know, well, 3D Tetris is probably a good way to explain it. And as soon as one piece doesn't land the way you wanted it to, or the way you were hoping it was going to, then all of a sudden everything builds up, and you've got to scramble to try and, you know, and clear the row, so to speak.
So, Anthony, what is the consequence of you not being able to do your work if you don't get access? Are there going to be outages straight away? Is it going to be that the reliability of the network will be less and therefore it's prone to more, or it could be all of the above?
All of the above, because well, it's also that whole lost opportunity thing as well, because if you can't get the work done, and there's not alternative work you can do in its place, then that's time, effort, and opportunity lost for everybody that you've got to try and make up later. Then you've got risks to the assets of.
And sorry, just 1 second, because I want everybody to be playing this in your own environment, because these are really important questions. Who pays for that, Anthony? If you've got a team that you've set out, and you know the issue with transmission lines is that it's over long distances. So you're going to send people out to the boondock somewhere to go and do an inspection or a fix or something. And if it's not available, and I'm saying the same thing would apply if you're going to do a shut, or if you've got some routine maintenance that you're going to do. You might use contractors, you might be doing it yourselves, you might have, you know, manufacturing has said, because I see we've got some manufacturers here, yep, you've got that slot, we put it into our production schedule, then something happens and it doesn't. So who ends up, and what is the system impact? The system being, what is the business within so the maintenance always sits within the context of an overall system. And that system is there to do a job of work, either to provide water or to provide electricity. If you're providing electricity, you're getting paid for the electricity you supply. If you don't supply the electricity, they're not getting any money. But who pays if this 3D Tetris doesn't quite work as you expected?
Well, it sort of it depends on the scenario, and I guess sometimes the customer and how much work you have in that area. We always look to have a plan B for those situations, so that if the plan A work can't occur, then we can switch to the plan B work. But sometimes that's not always possible. The situation doesn't allow for it. And then that all comes down to whatever your commercial arrangement is with your customer around those situations. Obviously, if it's, through our own error, well, then that's on us. So, I think everybody has that same experience where if you make the mistake, then, you're going to pay for it off your bottom line.
Okay. Let me move through some of this, and I'm going to come back to those questions again. Okay. So the constraint is the system bottleneck. And so one of the key things that I want you to do while you're listening in is to think about, well, what is your system? Because your system is defined. You have to define it in terms of 2 dimensions, space and time. So you've got to say, maybe over a long period of time, you might have in your organization some kind of capital project or an expansion project or something like that. So you could say, well, the current constraint sits here. But from a systems point of view, once we finished with the big project, it's now going to be somewhere else. And then there's also a space issue, where you could say we're operating in this particular part of the plant, or we're operating in this particular geography for the moment, which means I can't get to the other place. What is it around this particular space? And it doesn't necessarily mean I'm going to put the taxis up there, because what it could be is that, is the constraint, everybody's been to the airport when you've been trying to get a taxi and there's a long queue. The constraint's not necessarily on the road where these taxis are, in the parking lot where the taxis are, but about what is the system that actually manages getting passengers into the taxis to take them away. And I want to make the point that constraints govern the rate of value creation, right? And value is not created. I'll make this case, and you can please feel free to jump in if you disagree. Maintenance doesn't create value, right? The system, the business, the operation is what creates the value. Maintenance is the enabler of the creation of the value. So pretty much what you see there is the pit crew is us. That's the maintenance people. The car is the business. And the idea is to keep the car on the track as much as possible and to reduce as much as possible the time that it spends in the pits being maintained. We're all cool with that metaphor. That's kind of, we're the guys that are standing around there doing all of that stuff. And what we want to be able to do is to get in and get out. And if we can get in and get out quicker, to take Anthony's world, and you could, even if we've got this sort of 3D, 4D Tetris or something like that, if we can get to our work, get it done to quality, get it done on time, that we're fully kitted going in and we're making the most out of the time that we have available, then we're going to deliver the most value for the business, because the car can keep going around the track, because that's what wins the race, is the more time that the car spends on the track. Which means you've got to ask the question about what's the job of the pit crew at that point. While the car's busy driving down the track, what is it the pit crew should be doing, right? And I'm going to make the claim, and I'll back it up as we go through this presentation, that constraints govern the rate of value creation, and therefore, by definition, non-constraints have got capacity available. So here we go with the definition of the theory of constraints. And this is why I say that it's a science. It's grounded in reason. It has the same weight as the theory of gravity. And that's why I would encourage all of you to take a deeper look at it, because it can provide you with an unbelievable improvement in productivity for not much more than thinking about things in that way. So why do I make that claim? Because the theory of constraints says, in all of its glory, that no system can produce an infinite amount of output, right? So I can't do a shut-in zero lead time. I can't finish a piece of maintenance work without any resources. There's something that prevents me from getting it done in zero time and at no cost. What is that thing? And that's simply what the theory of constraints is. It says that there is something that does that. But furthermore, what the flip side of that equation is that if I have a constraint, if there's a thing that prevents me from getting more of what it is that I want, and maybe just to make it a bit easier for people to, hello, Guy, to make it a bit easier for people to get their head around kind of that idea. Let's say, for example, that you had a project. Let's say you had a shut. Let's say you had a Gantt chart for a shut, and you identified what the critical path is for the shut. Well, the critical path is the constraint. And what it also then means is that which is not on the critical path, technically you'd say that it's got to float. So whatever it has can start early or late because it's not critical, has got capacity available relative to the constraint. So you'd ask yourself the question, why would I go and do non-critical work when if I'm doing work on the critical path is going to reduce the duration of the shut? And then and I will be able to hand that back to service sooner and be able to do those things. So we'll revisit those ideas to just reinforce them. But let's talk for a moment about what's the goal, right? And I am talking here, and I will talk about for-profit organizations. Does anybody want to talk up if you are not in a for-profit organization or you don't do any monetary billing, that it's a pure sort of service play that you're in? Anyone? Everybody's business that they're in, and anybody on this call is in the money-making business one way or another. So if that is the case, then what we're saying is that what we all want is a return on investment. What we all want. We all have super funds, and in our super, what we want is we want our funds to make more money now and in the future. And we measure that as a return on investment. How much capital is tied up in the business we're investing in, and what kind of profits am I going to get as a consequence of that investment, right? And in the world of the theory of constraints, there's this piece called constraint accounting, which is very, very useful because it allows us to look at a situation and say, what is my local action in this particular place going to have as an impact on the overall financial implication for the business as a whole? It seems to be a big ask to say, you know.
No.
Sorry, somebody had something? No? Okay. So what we define these terms. So return on investment, I think everybody would be familiar with. This is a really important one, throughput, right? And throughput in the theory of constraints world is a financial measure. It's not a production measure. We would talk about output of tons or units or liters or gigaliters or whatever. But throughput is a financial measure, which is made up of sales. That's what we actually invoice, right? Which is tons or units times the price, minus the variable costs. And the variable costs are those costs that don't get incurred unless I actually do a sale. So you can see here it says COGS, which is what is my cost of goods. And then I might pay commission, royalties, freight, right? Note that labor is not in there, right? Labor is not a variable cost typically. Labor will be, the only time when labor is a variable cost is when it's piecework, when you're saying, I will pay you for each ton produced, right? But generally speaking, that's not the case. Anyway, that's what throughput is. The next thing is operating expense. This is where the labor comes in, right? Labor, contractors, other operating expense, maintenance equipment and materials and the like, okay? This here, throughput minus operating expense, anybody here is a management accountant, this is a thing that they call contribution margin in management accounting. And so this here is profit. If I make this amount of throughput, which is my sales less my variable costs, that goes towards paying my bills, which is my operating expense, and the difference between the two is my profit. Okay, so that's pretty clear. Sorry, someone's mic is on. If you can. Radu, yeah, that would be you. Okay. And then what I've got is I've got investment, which is all the money trapped in the system. It's the current assets, the fixed assets, less the current liabilities and the long-term liabilities. And so this gives us a really useful idea about what is throughput minus operating expense divided by investment gives me my ROI. And when I look at this, simple, basic math tells me I want to increase my numerator, the guy at the top, and I want to decrease my denominator, the guy at the bottom, if I'm going to maximize my return on investment. And it's pretty important for us as maintenance people to actually put ourselves out of the weeds of doing the maintenance work and to think about our system and to say, what is it that we do that creates and enables this, right? And one of the reasons why I particularly like working, for example, in mining, is that if you're take a shut for an example, if you can reduce the time of a shut, it's highly consequential. Often it's hundreds of thousands, sometimes millions of dollars a day that you're actually going to be, that you will be able to make. There's like more rocks on ships as a consequence of being able to do your work in a shorter period, right? And the consequence the other way around is also very, very heavy. It's misguided to think that if you save on doing required maintenance to produce the reliability that you need, and just ask anybody if you've had break-ins or you've had unplanned breakages, and so you constrain, if you like, production, you know, and then all hell breaks loose, and you've got to find the resources and make it happen, and it's an awful thing. So what we want is to generate the cash. We want the throughput to go up. We want the operating expense to stay the same and the investment to stay the same, or hopefully go down. But the point that we make is that you can only reduce your operating expense by so much. And somebody said a bit earlier that when it comes to maintenance, it's usually quite a big ticket item. If you look at all the people that are there and the contractors that you use and all of that OPEX, and they're going to be saying, can't you take some of that out and still do the work? There was one particular company that I did work for, and they had the geniuses from McKinsey come there. And they just arbitrarily said, we're going to do shuts we're going to do the campaigns 4 years instead of every 2 years, right? And left, and it was great for the year that McKinsey was employed and paid their big fees, but it was absolutely appalling when it came to 2-3 years down the track in terms of how much remedial work had to be done to get them back into good nick, and how many unplanned outages there were and the like, right? So we want to make sure that this is the correct size. We don't want to be wasteful, but by the same token, we want to make sure that it's properly funded so that we can actually provide, and that everybody's in this main game of saying, can we use the assets that we have to deliver more contribution, right? And then likewise with the investment side, you can't go down to zero investment. You can't say, I can run a business without having any capital in it. And so there's a limit, a theoretical limit below which you can't go. And we need to be very mindful of that. So if we take a systems approach, and here's my whole space center, and I've got rockets, and I've got all of that stuff going on. So here's the theory of constraint stated again, that all systems are governed by the constraint. If this were not the case, output would be infinite. And you can see this sort of picture of a perpetual motion machine on the right-hand side. And then there's another condition, or it would collapse to zero. The system ceases to exist, right? And I don't know how many of you are into the whole entirely renewables idea that we have going on in this country at the moment. But we're about to come to this collapse to zero part on the basis of saying that we are only going to go renewables. We're not using gas for firming. We're not going to use nuclear. That's the current policy of the government. And the whole electrical system is going to collapse in a sticky heap, not to mention all of our manufacturing and everything else. It's just basic physics. When physics takes on ideology, physics usually wins. But that's an example of a collapse to zero. I hope we don't get there, but it looks like that's where we're headed. So I invite you to think about your system. Here's a really simple sort of schematic, diagrammatic picture of a system, right? And for all systems have in common this idea, at least we think it's a good idea, is that we want to maximize the output with minimum effort on the input. So I've got all of my inputs. It could be people, it could be materials, it could be knowledge, it could be whatever it is that you've got as an input coming into your system. You crank the handle and apply the effort to that, and you get the output, which to some extent is value. And nobody put their hand up to say that they're not in a for-profit business. So for the vast majority of businesses, the output eventually turns into revenue, and then those pay the costs, which is the effort. and there's the input. So one thing, again, what I would invite you to do if you're going to think systems thinking is think about, like, what is this boundary in both space and time? Are you talking about your facility? Are you talking about your piece of equipment? Are you talking about the company? You know, each one of these things would then yield a different answer in terms of what is the, where do we find the constraint? And what do we want? You know, if we were saying at a most generic level, what do we want? We want agility. What I mean by agility is that we can respond in short lead times. We don't have to, we're not, it doesn't take us a long time to respond to something that's actually happening. It's all very well to have plans, and I'm a huge believer in planning, but stuff happens. So you need the agility to be able to make your plans flex. Then you want reliability. And what I mean by reliability, I know that in the world of maintenance, reliability means, you know, to what extent is it available compared to what we said that it would be available, roughly speaking. But in here, reliability, I mean in terms of due date performance. So if we're going to perform a piece of maintenance, there's an expectation from operations that says you will return to service on such and such a date or at such and such a time, because then in their production schedule is dependent. They're playing their game of, you know, 4D Tetra and everything else like that to see that you can give it back. And so to what extent can we bust our bottlenecks by reliably, meaning we say what we're going to do and when we're going to do it, and it is done when we say we're going to do it 90% or 95% of the time. And then the third thing that we want is quality. And for me, the simple measure of quality is about how much rework do we have to do? To what extent can we get it right the first time? So I think that is an overall generic statement of how do we maximize output with minimum effort on the input. We need to be agile, we need to be reliable, and we need to be quality. Let's take a little bit of a deeper look into our system, and like, you know, 99% of all things that we do are made up of chains of events. So we go from the left-hand side and we head off to the right-hand side, and there's these dependencies, there's these sort of links between them, right? I've got to start process A, and then I do process B, and then I do process C, and then I do process D, and then I've got the output, right? And this system might be my maintenance system, right? This system might be a shut. The system might be repairing a pump. You know, you can think about it at whatever level that you want to think about it, and there will be process steps within that, and I get the output. You know, I've got the input of all my work instructions, and, you know, I do my JHA and all of these things that I'm fully kitted. I work and I do all the work that I need to do, and then out the other end comes a nice fixed pump or whatever the case might be. Then we have a look at capacity. We say to ourselves, okay, well, how much capacity do I have to do what I need to do? And we see at the end here, we say, oh, well, I've got a demand of 10. And there's 10 widgets that have got to be done. And then I say at this step, I've got the capacity to do 20. At this one, 14. At this one, 10. And at this one, 20. So each of these steps, you could think of it a slightly different way. I could have written it and said, how many hours does it take to do each individual task along the track over here? And the longer tasks would mean that I've got less capacity, and the shorter task means that I've got more capacity. Is that okay so far? I'll take that as a yes. So what happens is that a manager looks at this and says, well, hold on a second, I've got too much capacity. If I only need 10, why don't I just scale everything back to 10, right? Why don't I say that, do this? I've saved myself the cost of all these extras that I don't need there. Let me see if I can get balance of everything that I'm doing, so that I just have waste not, want not would be the mantra, right? And I'm sure you've all faced that. Is they say, well, why is that guy standing around doing nothing, right? You've thought about everything that you could possibly allocate to them to do, and there's nothing left for them to do. And so say, well, they should go. And keep in the back of your mind what I said earlier about, if there is a constraint, then by definition, non-constraints have capacity available. The trouble with something like this is that if you've got a 90% probability of delivering 10 units of work out of this, and another 10 out of this, and it's only 90%, and 10 out of this, but it's only 90%. You might think that you're going to get 10 out of there, but the probability is actually 90 times 0.9 times 0.9 times 0.9 times 0.9 times 0.9. So you've actually only got a 65% chance that you're going to get 10 out of the other end there. That's a really big deal, and that's something that most people are not explicitly aware of. In statistics, they call it covariance, where I've got variation. You know, let's say that I've got, you could say that I've got 10, you know, I've got 4 pumps that I've got to do today, and all 4 pumps need to be working in order for that line to be brought back on, and I've got a 90% chance of doing those pumps with 10 units of work, right? But I've got to have all of the pumps done in order for that line to actually be switched on and for that to be working. And I've only got then, in this case, a 65% chance of them being returned to service on time. That's a big deal, right? Because we don't pay explicit attention to that. And what will often happen is that we'll make up for the difference between the 65% and what we thought would be the 100% by working overtime, by cutting scope, by compromising on quality, because there might be this big imperative for return to service at a particular time. And you say, I don't understand. I looked at each of the individual parts of what it was that we had to do, and it seemed to make sense, and it seemed like I could do it within the time given. But for some reason or another, you know, when I came to the second pump, the parts weren't delivered. I had to go and march off back to the warehouse to go and get what I needed, right? And so on and so forth. It's only the case when there's no variation does the whole equal the sum of the parts. So if this was 99.99 and on, then 10 here in a sequence of events would equal 10 here. And so you might say, oh yeah, we've got a big initiative going on where we're doing Six Sigma within our system. And what we're doing is that we're removing variability. That's what we're trying to do, statistically take away the variability. Good luck with that one, right? Good luck if you think that you can do, you know, what's the 3.4 defects per million opportunities that you have. It just doesn't work in our world of maintenance. You know, a lot of it is inspection based. A lot of it is emergent. As you open the cover, you find, oh, we've got to do that. Or sometimes you look at it and say, oh, that's okay, that'll do until the next time I come around. Because what happens, even if I did get this inside of my system, if I've got only 90% probability of getting the inputs that I need. Let's say I've got, in this case, 5 different vendors who are supplying me with materials, for example, and all of them are pretty good in their own right of supplying those materials at 90% DIFOT, right? If I put them all together, it means that I've only again got a 65% chance that all the pieces are going to be there when I need to work on them. And what happens if the demand changes? What happens if it went down to 9 because we didn't do something, or it went up to 11 because there was an unplanned breakdown, which I've got to go and deal with? So let's go to the art and science have their meeting point in method. Let's talk about the 5-step focus, which is the kernel of what I want you to take away today, right? And it says that about managing systems. So number one, bear in mind what I said before, is that what you need to do is you need to define what is the boundary of your system. So I urge you, just write down on a piece of paper in front of you now, what is the boundary of your system, right? Because I want you to go through this exercise of the 5-step focus to get into to start that process of thinking about, well, what is the constraint, right? So, you know, maybe you would say it's the maintenance department or the maintenance function, or it's the asset management function, or it's the business as a whole. I don't know, whatever it is that you think that it is. You know, I think that with Anthony, you know, you provide a service to other people. And what's kind of interesting, if I just go all the way back to here, if you're a service provider to somebody, right, remember your throughput is their operating expense or their investment, depending on how they want to treat what it is that they pay you. So there's a natural kind of tension there, because you want to increase your throughput as much as you can. They want to reduce their operating expense as much as they can. But your throughput, what you're invoicing them, what makes you money and makes you a profit, is actually what is their expense or their investment. So there's a kind of natural tension that exists there. We'll sort that out a little bit later. We'll have a talk about that. So you've defined your system, right? So the first step is, if constraints govern the rate at which value is created, the first order of business is find the constraint, right? What is it? I'm looking at Ian and thinking of all the great work that Mainstream does. And well, obviously what you've got to do is to say, well, what is Mainstream's goal, right? Where does Mainstream want to be in 2 years, 5 years? And maybe you ask the same question about your system that you're looking at and saying, well, what is the goal? And then relative to the goal, what's the constraint? Find it. And the constraint will exist in one of three places, right? It's going to exist in supply. So you could say, well, let's say that you're resource heavy in maintenance. You need really good quality engineers. You need good tradespeople. You need the full mix of what it is that you're dealing with. And like I had in the refrigeration business, there was a tremendous shortage of those kinds of people. That would be a supply side constraint, right? Potentially it could be on the material side as well, where you could say, oh, I've got long lead time items. It's always a problem. We don't know what we need. We don't know what we want or what we need. And it's never on time to do when the maintenance event occurs. The second one is about is about, have I got the capacity to make what the market is calling on me to do, right? So that would say I've got an availability, might be the boundary that we have of our system that says I've got this time box in which I can do this. And no matter how many people I throw at it, I haven't got enough to actually satisfy all the work orders that need to be done and all the operations that need to be done to give the asset back to them in the kind of condition that the reliability engineers have dictated or the strategy dictates or whatever, right? And then the third one would be the marketplace, which would say, let's say as an example, we can do all of the maintenance that we need to do, but nobody's buying what we got, you know, or if you're in a commodity that the price of the commodity is so low that we're producing it, every time we produce, we sell at a loss because it doesn't cover our overheads and our variable costs. So we need to do something to find new markets, right? That was in the coal industry here in China. Remember that they sanctioned our coal, and all of a sudden we had to go and find other markets for the coal because we could still keep producing, but we weren't able. So this idea about find the constraint is strategically, where do you want it to be, right? What is the place? And find is more of a design issue. It suits kind of engineering types because you're thinking of it from a design point of view and saying, not where is it? Oh, it's Monday, Fred didn't turn up and that's the problem. You're talking strategically then, is it's a design problem, saying, well, where do I want it to be? Do I want it to be in supply? Do I want it to be in make? Do I want it to be in the market? And it might change as it goes through its cycles. So I keep coming back to this idea that maintenance, in a sense, the maintenance bottlenecks, if we're talking about busting the bottlenecks, is giving production more time to produce. That's the purpose of maintenance. That's why we maintain. You know, otherwise, we don't make any money ourselves out of anything. We only keep the equipment in the kind of nick that it needs to be in so that they can have as much production as possible. So that's an idea to think about and to point you to navigate towards, well, what is the constraint by design, right? And it might be, well, what we really want to do is those things that I talked about earlier. We need that agility so that we can roll with the punches. This is not available, but this is, you know, Anthony talked about, we can choose, you know, we have a plan B. In case something happens, we can go and do the other thing because circumstances dictates that. But that certainly what we want to do is to have that agility. Number two, we want to have the reliability that we are able to make a promise that we can keep, to say, we will give this back to you then, and it's going to be in top working order. And it means we don't need to come back and look at it again for another, pick your number, 6 months, a year, or 2 years, or whatever. And then we also want to make sure that it's quality. We don't want to come back and have to redo the work, right? We want it to be right the first time. We don't want the rework to be happening. So it's a very, very important question to ask yourselves, to say, within the system that we're looking at, what is it? And again, on that piece of paper that you've written what your system is, I invite you to then say, well, what do you think would be the constraint? And we'll give you some bigger ideas on that in a minute. Number 2 says, if constraints govern the rate at which we deliver value, and I have correctly identified what it is, then the next step must be to optimize it, because I'm going to create the most amount of value if I'm optimizing. And in 99 cases out of 100, the optimization step is about scheduling. It's about where do I apply the resources that I've got in order for me to get the most that I can out of my constraint. What is the trade-off that I'm going to make between throwing resources at something which will reduce the turn time by X versus saying, well, I want to save costs, I'm not going to put the resources on it. And those are the kind of trade-offs, when you remember that throughput, operating expense, and investment equation, those are the trade-offs that you really need to know. And I really think that there's a big case to be made for maintenance people to be business finance literate, to really understand what does a day cost if I bring this thing in earlier or not? What is the cost to the business if I repair this thing properly and never go back to see it again for the next 3 years versus not? And so that you're able to mount the case that says, I therefore need, for my optimization, this amount of resource. And, the third part is about collaborate around it. And these two, the optimize and collaborate, are actually two sides of the same coin, right? Because what that's saying is, I can't optimize if I don't have everybody else collaborating around it. Let's take, just by way of illustration, a shut, right? If you're working on the critical path on the shut, and something happens, and you say, I need another fitter, or I need a boilermaker, or I need 3 boilermakers, or whatever the case might be, you should be able to put your hand up and say, I've got into a problem here. You guys have got float. You're not on the critical path. Step over here. In some sense, just close off neatly, but drop what you're doing and come on over here and help me to make sure that I'm keeping on track with what my optimized schedule is to do the work that we need to do, right? And it's not necessarily that it has to be a shut. It could be that you're doing routine maintenance and you know that the particular thing that you're working on is absolutely critical to production, where somebody's doing some discretionary piece of work somewhere else. Or you might have a contractor that you can call on demand with a little short notice. You can mobilize them. That's what I mean by collaborate, is the ability to be able to subordinate your own optimization, if you like, to what is good for optimizing the system as a whole. Okay, so these are really, really important in terms of working together, and it's in these that I maintain you can get yourself a 25% improvement, right? You will get through 25% more maintenance jobs. You will reduce the turn time of your shuts by 25%, and on it goes. That's what I'm talking about, real, tangible value that you're able to deliver to the business as a consequence of doing these 3 things very, very well. And I think it's worthwhile to mention now, and I'll show you in a minute, one of the things, maybe we'll have time for 2. But if you think about it as a hierarchy of theory of constraints, so there's the theory, which is call it the falsifiable hypothesis part, which says systems produce value in accordance with what the output of the constraint is, the rate determining step, right? And so you're not going to get more than that, which means everything else. And I'll give you an example, because I've done a lot of work in the alumina business. And in the alumina refineries are designed that the digestion is the place. So when you put the bauxite and you mix it up with the caustic soda and you in the crusher, that's the place that has got that is the rate determining step. And then your calciners and everything else have got capacity. They can take it away faster then you can actually do the crushing and everything else like that. So it's pretty clear to everybody that if we lose a day's production or an hour or a minute at input, as they call it, then that's an hour lost for everybody, because we can never make that back again. And that's what the maximum is that it can do. And so in your systems where you've drawn your boundaries, to think about, well, what is that? What is the ceiling, the limit that we can do of it? And what do we need to do to optimize that? And then how do we all collaborate around that proposition? How do we make sure that we are subordinating what we're doing in order to do what's best for the system as a whole? Because if everybody's optimizing their own thing, I dare say all we get is like a cacophony. We just get chaos, right? And the next step is uplift system performance. What does that mean? Well, that means if I've squeezed all the blood from the stones over here, at some point it's going to be get more stones. So if we go back to what I said initially about supply, make, and demand, or the market, then it could be the case. And I mean, I'll give you an example just to illustrate, and you can think about it in your own terms. I've done a chunk of work with major projects at BHP, and this was sort of back in the day when they were spending $3-4 billion a year on expansions, and would go mine, rail, port. In fact, the rail would be skipped out quite a while, because it would just be mine, port, mine, port, mine, port, until rail was completely clogged. And they had to then put a second railway line all the way from Newman to Port Hedland, because they had to open up the rail part of it. But you'd see this thing going between, for the most part, between port and mine, right? And so the uplift part of it was always the case of what's going to happen next. So I make a big investment in the port, in my stacks and my reclaimers and my ship loaders and all that stuff. And that means now I can go at 100 million tons at the port. And he said, well, I'm not mining fast enough. So now I go back to the mine. And that's the uplift step, is the investment side. So uplift is always an investment. Where are we going to make the investment such that we will lift the overall capacity? We'll be able to make a step change in our system's ability to do what it is that we need to do. And I'll just offer to you, it can get quite sophisticated and nuanced when you're thinking about it. But, it might be that the uplift step would be, for example, an investment in a digital twin, or you're going to put in more IoT so that you've got condition monitoring, and you're able to more, you can do sort of, your predictive maintenance can be a whole lot better as a consequence. That's still an investment. It's still putting in systems that allow you to do that kind of thing. And then once you've done the uplift, then it's start again, because the constraint will have moved. Constraints don't go away just because you improved it in one cycle. You keep going. How are we doing? Ian, just a quick check-in. Are we okay?
All good? Yep.
Okay, so we press on. Any questions, anyone, just whack them into the chat. I will have a look and see.
Nothing as yet.
Okay, so please do put some questions in there if you've got them, and then I'll see if I can address them on the fly as we go. It makes it more, it means that I can sort of focus myself more on what your actual needs are, rather than me just waffling on. Hopefully there's enough there for you to chew on, but it's really interesting to see what kind of questions you come up with, to make sure that I'm actually addressing what your needs are. All right, so we've got the 5-step focus. This is super important. Honestly, if you get nothing else from this class today, that's it. If you can get your head into this, and you can, and again, at our website, there's a lot of, if you go to the, under resources, there's a piece that says articles, and I've written a lot of articles about this. This is the key. I say to people when I'm doing my work around the place, is that whenever I get lost, whenever it becomes a bit fuzzy and it all seems to be complex and everything else like that, I always return to the 5-step focus. And it's nice that it has the acronym FOCUS, because it just means you can remember: find, optimize, collaborate, uplift, start again, right? And the key thing is, you define what the boundary of your system is, you express what the goal of that system is, and then you ask yourself those questions. Remember, the focus step is not about where is it today by happenstance, but by design, where should it be? And so that's a question to ask. So where would you design the constraint to be in this system, right? Well, pretty clearly it's over here, right? Because this is it's got a capacity of 10, and it's the rate determining step because I can produce more here. These are work centers, and this is, let's take my example of and I'm going to horribly simplify it. Sorry, just let me close this door a second. So what you can see is let's say this is, I can, drill and blast and run a mine there. And over here, I can put it through the primary crusher. And here, I've got to put it into the digestion. So this is where I'm going through the secondary crusher, and I'm putting the caustic soda in and everything. And out here is I can calcine that much. So we say, well, this is the drum, right? And why the drum? Because it beats the rhythm of the whole system. That's the name of this Goldratt invented the theory of constraints. Has got a production system that he calls drum buffer rope. I'm about to show you drum buffer rope and how drum buffer rope works. So theory, methods, drum buffer rope for production scheduling, critical chain for project management, and there's a thing called dynamic buffer management, which is for supply chain replenishment. How many parts do I need to carry in order to be able to keep everything fully kitted when they need them? We call it the drum because it beats the optimum pace, right? So optimize 10% at the constraint is 10% for the system as a whole. That's a really big thing, right? Because if I get 10% here or 10% here, all I'm going to do is build up work in process in my system. I'm not actually going to get any more out. But if I get 10% at the constraint, it means that I can get actually 11 out of here, which is huge. And we don't have time today, but there are countless stories I could tell where something really quite simple, when you see it afterwards, right? If you got that increase there, that actually creates a system output, which is, you could imagine if I can increase the digestion by 10%, that's 10% for an entire alumina refinery, which is huge. It's absolutely huge. The constraint can't be optimized if the rest of the system doesn't collaborate around that proposition, right? So how do we do that? Well, we create a buffer over here. Remember I said drum buffer rope? Well, here's the drum, there's the buffer. So what it's saying is that, in a sense, what this blue bar represents is a store of the upstream capacity, right? So it's saying, let me put that in place there. And I want it to be sort of just right. I want it to be the Goldilocks size. If I make it too big, I'm just going to be drowning in work in process, and I don't know which way is up, and then you're going to land up with all sorts of problems of multitasking and thrashing around, and do I pick this one or do I pick that one? But on the other hand, if I make it 0, it means that any delay for whatever reason that hits the drum's going to miss a beat. And if you recall, what I said was that the optimization of a system is 99 times out of 100 a function of scheduling, right? And so if I miss a beat, that beat never comes back to me. I can't recover that, right? So I need to make sure that I've got a buffer. And this buffer might be the plan B, right, that we talked about earlier. And that says, well, I couldn't do the thing that the drum was scheduled to do, but I still can do this, and I'll come back to do the other one. So lots and lots of interesting conversations. But the final part of it is a rope, right? And there might be people here who have done a little bit of lean, and in lean, you'd have this notion of, one thing is the takt time. So the drum is quite similar to the takt time in that it's actually the rhythm that the system's actually going at. And then you've got this other idea of the Kanban, right? And it says, okay, well, here's a signal that says, when one lead time away is what this rope is. And it says, so don't flood the engine with work in process. But when the drum has done its piece of work on a unit, then go and release the next batch that goes in there to fill the drum. So you've got this kind of replenishment piece going on, but it's based on a pull signal. So we actually, one of the key things about theory of constraints is that it is, and drum buffer rope for that matter, is that it is a pull-based system based on what work you are actually completing, not push-based that says, and like how many of you have got, you know, I don't know, anywhere from hundreds to thousands of job cards that you've got to do in a given day, and it's just, you know, there's one particular client that I had that got 10,000 a week, and they know they can only get through 6,000, right? And so it's always just sort of flooding the engine with all of this and saying, like, how do I make sense out of which ones? Sometimes you can say, all right, I've got clarity, these are regulatory, I've got to do them because it's a safety issue. And there's a whole bunch of other ones that say, well, how the hell am I supposed to know? They just keep rolling over week after week after week, right? And whereas what we want to do is we want to say, well, what are we actually capable of producing? And then let's pull it through the system at that rate, right? Then is the uplift. So it says, all right, I actually have more demand than I can deal with. Yes, to squeeze all the blood from the stone, get more stones. Well, if I do that, I've got a combined capacity now of 20 over there, and it exceeds the demand. So now the drum moves to here, whatever this particular process was. So you need to then start again and say, okay, now that I've got a capacity of this system being 14, what can I do on the demand side here that would potentially get me to a place where I can actually do 14, where I can satisfy, or my system is producing as much as there. So this was a little bit like when I was talking about, this might have been, you know, at the mine, we added an additional capacity. So the drum moved to the port. And then it said, okay, well, what's the consequence then? And what do we do? Because it's started again. But the drum buffer rope, now the buffer would be in front of this new drum and the rope would be there, and so it goes, right? Time to find more demand. All right, with what little time we've got left, I'm just going to, so that's a drum buffer rope. What I'm going to do is I'm going to just look at the shut, and hopefully it's interesting even for those people who don't do shuts, because the general principle here would be around the critical chain project management. So here what you can see is a power station, and here you can see a calciner, and this is the schematic of a calciner. And probably most of you have got something that represents this, a major events calendar. One way or another, you've got all the pieces of kit, and you're putting them into a timeline to say we're going to be doing this event then, that event then, and that event the next time. I don't think we necessarily want all of that. What I want to be able to do here is to say that when we're looking at the constraints, if we say find the constraint, we want to be able to say that the constraint is here, it's this, it's the critical chain. I've suppressed all the other stuff around here, which is all the non-critical chain stuff. And what I need to be able to do is to see to what extent can I actually deliver that between January 23 and July 26. All of this work needs to be done. And what I land up doing is I've got a dilemma when it comes to sort of project work in maintenance, in fact, in anything, but maintenance in particular, is I'm saying on the one hand, what I want is a sort of more or less kind of simple network to show me what is the flow of work and where's my critical chain. But I don't want it to be like so detailed that I can't follow it and it's bound to be wrong the minute that it makes contact with reality. So I've got this dilemma here, which says itemize every task, because I need to give work instructions to people. I need to mobilize people to the specific work front that I want them to work on, to do the specific piece of work. It's got all the information that they need to do it. But on the other hand, I want to only capture the main activities, because I need to be able to see, well, how does all of that work flow and how does it make sense together? And how do I control at the macro level while giving autonomy at the micro level? And there's a way of doing that within the theory of constraints, where we say there's a top tier task and there's second tier tasks, and they can work in different modes. I don't want to go into too much detail about what that is. But really what I wanted to do here was to just make the point that when we're thinking about constraints, we're saying find the constraints, there it is. If we're saying optimize, remember I'm using that acronym FOCUS, so you can think about it for yourselves. You can say, all right, well, find the constraint in a project. It's always going to be the critical path. In fact, we call it critical chain because it's a resource leveled critical path. Okay, so we're saying I've got to take into account what resources are there on each one of these tasks over here. Then collaborate. That means that if I had, and unfortunately I'm not showing it here, if I had a feeding chain in here, then it would be, can I take people off of this and put them onto here where this is falling behind? That would be the collaboration step, right? And then, by the way, on the optimization, once you've got the first cut of it, you might turn around and say, I wonder what out of this, could I do these things sequentially? Could I do these things concurrently instead of sequentially? So that you're doing all the work that you need to do to collapse what the time is. Because what you should have hanging off the end here, what is the implication in terms of throughput, operating expense, and investment? So what is the financial implication of a day that I either win or a day that I lose, right? And that's something that I get on a bit of my high horse there, because it's so seldom that I actually find that people actually know what that is, right? So I invite you all, you've got your little picture of what your system is, but even if it's not that, then I invite you to think about, of all the work that you're doing, and whether it's in shuts or whether it's in routine maintenance or whether it's in breakdowns, whatever it is, do you know what is the implication in terms of throughput, operating expense, and investment? So I'll give you an example that happened, a real live example that happened in the shut, where we looked at the thing, and this was to take a vessel which was refractory lined and to make a call as to what was the critical chain being resource level critical path. And we got to a number, 53 days or something like that. And we said, well, can we do better than that? And the way that it had been prepared was to say, we'll shut down, and then we will go in, we will erect scaffolding, we will do all of the demo of the refractory, and then we will cut the vessel and remove the vessel, remove the scaffolding, put the new vessel on, put the scaffolding back, do the refractory, and then get out of there. And some bright spark turned on and said, well, we could probably cut the amount of time that it takes overall by a significant amount if we could just do the lining of the vessel before and we lifted the whole thing. And somebody responds and says, that's crazy. The kind of tonnage that we need to lift, we'd have to get the biggest crane in the Southern Hemisphere. Do you know how much that costs per day to hire that? And so anyway, that conversation moved forward, and it turned out that the benefit to the company by actually doing that was way more than the cost was of hiring that particular crane. And so they did it. And it meant then that you could take out all of that in-between time of the scaffolding and the descaffolding and then doing the refractory only after you've put the vessel back together again, versus just lifting up the thing with the refractory inside it, boom, drop it down, weld it around, good to go. And in that kind of, I think there was 10 days or something like that was taken out, and it was something like $1 million a day. It paid for itself easily. So it's that kind of thing that you want to be looking at. And again, it's a nice illustration of this idea of what is the constraint and what is the dollar number in terms of throughput, operating expense, and investment that occurs if I can bring it in early or late. And then that's part of the planning part of it. And then what you want to be monitoring all the while in the execution is saying, okay, well, if I'm slipping, what's that slippage costing? And so, there might be, let's say, an overemphasis and a certain degree of neuroticism about, we've got to come in on cost, we've got to come in on cost. But you're not looking at, well, what is the benefit or the consequence of not doing it on time? And that could be something that is significantly more than you dialing up your favorite contractor and saying, oh, I need 10 more of these to get us back on track. So I invite you to think about, what is the consequence of a day early or a day late, both in terms of planning to help with your decision making, as well as in the execution when it comes to saying, well, what are the trade-offs if I was to get more resource or do something in a different way, or, you know, even sometimes maybe leave out scope and say, we'll do it in the next campaign. It's a risk that we're willing to take. So just to wrap it up, I want to just give you these mantras, which are, I think, really valuable to think about. So number one, and as I said, this is as solid as the law of gravity. This you cannot dispute. It's not my opinion or not something that's a feel good or anything. This is just raw science. And when I say falsifiable hypothesis, sorry, just 1 second. I've just got to get the room next door to be quiet. So the constraints govern the rate at which value is created, period, right? Number two, any system has one constraint that has the most impact. We looked at a couple of examples. We looked at the critical chain. We looked at the drum. And I'd invite you to think about, well, what is it? But before you can decide what is it and you can find it, you have to have a clear idea of, well, what is the system that you're actually describing? And what is the boundary of that system, both in terms of space, so what geographic area does it actually encompass, and time, so what is the horizon that you're talking about, okay? So you might say, for example, a shut, the one I was describing, the space is the calciner, and the time is the 53 days that it's going to take to get it done from feed off to feed on, right? And so what is that one constraint? I gave you an example where in a project world, it's the critical path / critical chain. And I also gave you an example that in the production system, and bear in mind that routine maintenance is a production system. It's like a job shop. It occurred to me not that long ago, I'm embarrassed to say, but that, you know, particularly if you're working on plant that's all over the place, that you don't bring it into a workshop. Basically, it's still a job shop. It's still saying, I don't know what jobs I'm going to get. I'm going to have to schedule each job and blah, blah, blah. So any system has one constraint that has the most impact. We talked about drums and we talked about critical path. Super important that a gain for the constraint is a gain for the system as a whole, right? So if we can do the turn times and return to service quicker without compromising quality, then we're going to we will bust the bottleneck of production, because they're always appreciative of the fact that you can give it back to them at good quality sooner than they thought that they were going to get it, right? So a gain for the constraint is a gain for the system as a whole. And here's a really interesting one, is that the constraint must do only that which only the constraint can do, right? So if we know what the constraint is, what we need to do is to have really proper means of delegation, right? And we need to be quite, what's the right word, mindful, I suppose, about the fullness of that delegation. What's the context within which you're delegating? What's the purpose of the delegation? What are the specific outcomes in terms of quality and quantity that you want to get out of that delegation, and by when? Those are minimum requirements to properly delegate. And so it's saying it's no good, you know, I don't know, if we used a sporting analogy, if you're going to have your star player, Lionel Messi, he's not going to go and spend all of his time doing things that everybody else can do. It's the constraint must do only that which only the constraint can do, right? So figuring out what the constraint is and then saying, don't waste its time doing things which are not its business. But the flip side to that is that non-constraints have capacity relative to the constraint. It's logically consistent. It's not something, if you have a constraint, and the argument, as I said, the falsifiable hypothesis is that constraints are a fact of nature, right? Until we have a perpetual motion machine, then constraints are a fact of nature. No business makes an infinite return on investment. If there was no constraints, then you would make an infinite return on investment. So, you know, some people have sometimes said to me, well, if they did do that, then I'd be out of business. I said, well, that's fine. I'll invest in the company that makes an infinite return, and then I don't need to work anymore, because it's just the perpetual motion machine, right? But so non-constraints have capacity relative to the constraint. And it's a question of how do they support? That's the collaboration step within the 5-step focus. How can they support the what delivers the most value to the business as a whole? Right. So we're kind of at the end. We've got 10 minutes for any Q&A if you want that. I've written a book about all this stuff. It's called More Than Just Work. And it goes with this idea that everyone has the right to be well managed. And I might just end on that note, because I kind of, in a sense, made it my mission in life to promote this idea of just work. And here it is. So bear with me for just half a minute, and I'll just read you the Just Work Manifesto from the book. And it says that just work includes my belief that it's possible to be just at work, to do unto others as you'd have them do unto you. Everyone has the right to be well managed. What might such a radical proposition as everyone has the right to be well managed mean? I figure it means that the people you lead through your management hierarchy properly understand the context of the work they're doing. They feel connected to the overall purpose of the enterprise and are aligned to its vision and values. They work to arrive rather than arrive to work. They're empowered with the requisite authority over the resources required to acquit all of that for which you hold them accountable. You know what you have called for is both reasonable and possible, given the human and material resources you place at their disposal. They have a deep sense of the significance of what they're doing and experience the world as a better place for them being in it. They feel safe to make mistakes while exploring new ways of being and doing. They're excited by the prospect of continuous learning and growth. So on that note, that's why I do TOC and why I'm so thrilled to be here with you today, is because hopefully it moves the dial in that direction. It brings order to the chaos. It gives you a quantitative fix on what do you need to do, what it is that you need to do. It can show you specifically, quantitatively, what is the value that you're adding, and what the efforts are that you make at the local level will have at the global level. And who knows, we might even create a somewhat better world. We might move the dial in that direction. As small as each of our contribution might be, if we all do it together, then it's got to be a good thing. So that having been said, thank you very much for listening, and I'm happy to take any questions you might have.
Fantastic. Thank you, David. Any questions, folks? We've got a few minutes. Any questions? Anthony?
I've got more, just want to share a thought that occurred to me when, David, when you were explaining the drum buffer rope scenario, it reminded me of issues with a complex system when you start having a series of faults, and that you know, your first fault happens, the weak point in the system fails and you fix that. And then it's not uncommon further down the track that you get another failure in that same system, but it's the next weakest point. And when I saw that constraint moving from one point to another after you've resolved that constraint, straight away it made me think of that experience with, some of the complex systems back in my trade days that I worked on, is that, when the first weak point fails, there's another one probably coming, because it's now going to suffer the pressure because of the first one being fixed.
Yeah, spot on. Absolutely spot on. I think that it's kind of interesting in terms of my own sort of personal journey around that. So I did mechanical engineering at uni, right? And coming out of that, I was very much, my whole mindset was made up as like everything should behave like mechanics see it, cause effect, and it's like it's logical. And when I first kicked off with theory of constraints, it was the same thing. And so this makes so much logical sense. Surely everybody gets it. But I think what's really important is that these all sit in the context of a human system, and the human system is, as you know, it's like filled with people's narratives about what's going on. So whilst it might be the case that in your days, as you say, when you were on the tools and doing the fault finding, you could find it and there's the next one. I make the joke that you've got, people have got free will, but more often than not, they've got free won't. So it's quite a trick to get that to make the transfer from what is just a mechanical thing. But the principle, and by analogy, it's exactly the same.
Thanks, David. That was great. There's a lot to think about and process from your presentation.
Cool. Thank you.
Brilliant, folks. One more question? If not, we will finish there. If you haven't already, join the mainstream community. There's heaps of sessions that we have had throughout the series and lots of other content there. And David's session will be recorded and available from tomorrow, so tell your friends. We have a session tomorrow with Noria. So if you're joining us then, it'd be great to see you. And if whatever you're doing for the rest of the day, have a great day. David, thank you so much for being with us. And it's been a pleasure. And folks, have a great one. Thanks a lot.
Bye, guys.
Thanks, David.
Cheers, folks. Thanks, David.
Thanks.
Bye.
See you, everyone. Bye.